The information is a measure of uncertainty. That means little the probability of occurrence of any message that conveys more information, more the probability of occurrence of any message conveys little information. For example, let us consider a dog bites a man. A man bites a dog. When I say a dog bites a man, it has no news or it conveys little news. When I say a man bites a dog, it has more news. I'll repeat again. The information is a measure of uncertainty. Higher the probability of occurrence, it conveys less information. Less the probability of occurrence, it conveys more information. You take these two statements. A dog bites a man. The probability of dog bites a man is quite large. It does not convey any information because it is the one often happens. Instead, if I say the probability of man bites a dog is extremely small, so that it conveys more information. That means when I say a message event is certain event, it does not convey any information. When I say there is an uncertainty, the meaning is that it conveys more information. One more example. Let us take the sun rises at the east. It always happening, right? So always the sun will rise at the east, so it does not convey any information. That means the probability of occurrence of sun rising at the east is very high, so it conveys little information. Instead, if I say the sun rises at the west, it conveys more information. It has more news, whereas this conveys little news or no news. So more the probability of occurrence of any event conveys less information, less the probability of occurrence of any event conveys more information. So the information is closely associated with uncertainty. When I say certain event, all the chances are going to be favor. That's what, if you find, it conveys little information. Now, since information is closely associated with its uncertainty, the information can be measured by information I is equal to log 1 by pk to the base 2. That means it will be inversely proportional to probability of occurrence. If we take this pk to the numerator, I can write it as minus log pk to the base 2. The unit is bits, where pk is the probability of occurrence of symbol k, probability of occurrence of symbol k, and I is, or ik, because information conveyed by the k symbol. Ik is the information carried by k symbol. So the information can be measured by uncertainty. The information carried by k symbol is given by log 1 by pk, or it can be written as minus log pk to the base 2. Why we have to put to the base 2 is because we assign only zeros and ones to the information by doing coding. So we have to put to the base 2, not to the base 10. The unit is, as I said early, bits. Now let us see some problems based on this. Calculate an amount of information. Calculate an amount of information if the probability of occurrence of occurrence of a message is 1/4 or 0.25. Now we have to calculate the amount of information. The amount of information is given by the formula Ik is equal to, either I can write log 1 by pk to the base 2 or minus log pk to the base 2. Now if I substitute, they have been given probability of occurrence of the message, that is pk is given as 1/4. By substituting probability of occurrence, we'll get information carried by ith symbol Ik is equal to log 1 by 1/4 to the base 2. If I take it to the numerator, I can write it as log 4 to the base 2. This can be written as log 2 square to the base 2, which can be written as 2 log 2 to the base 2. We know that log 2 to the base 2 is 1, so it will be 2 into 1, that is 2 bits. The unit is bits. So once you know the probability of occurrence of the symbol, you could be able to calculate information. As I said earlier, less the probability of occurrence conveys more information, more the probability of occurrence conveys less information. Whenever I say an event is certain, it does not convey information. Whenever I say uncertain, it conveys more information. This is about what is information and what is uncertainty. Now let us see what is entropy. It is called average information. Consider a discrete memberless source, capital M. Consider a discrete memoryless source we simply call it as DMS, discrete memberless source, emitting capital M messages, that is M1, M2, M3 and so on, MM, with probabilities P1, P2 and so on, PM respectively. I'll repeat again. Consider a discrete memberless source emitting M messages, M1, M2 and so on, MM, with the probabilities P1, P2, P3 and so on, PM respectively. When we say a source is a DMS source, discrete memberless source, whenever I say discrete, the source will have finite number of symbols. So whenever the source is going to have finite number of symbols, we call it as discrete. Whenever I say memberless source, the symbol emitted depends upon only present symbol. It does not depend upon previous symbol. That means the source does not have memory to store it. So the symbol emitted will depend upon only the current symbol. It does not depend upon previous symbol, or it is independent of the previous symbol, right? Now further, let us take probability of occurrence of message MI. Message MI is PI. Then the average information or mean value about the information, the mean or average information per individual message is given by average information per individual message is given by summation k is equal to 1 to m pk into ik. The average information per individual message is called entropy of the source, which is given by, or it is denoted by capital H. That is, capital H is equal to summation k is equal to 1 to m pk into ik. Already we have been seen ik is equal to, we know that the information carried by ith symbol ik is equal to minus log pk to the base 2. By substituting equation 2 in equation 1, we get entropy h or h of x is equal to entropy h or h of x is equal to, now substitute ik here, so you will get, since minus is there, you will get minus over here, k is equal to 1 to m pk into log pk to the base 2. The unit is bits per message or bits per symbol. Equation number 3. So entropy or average information is nothing but the average amount of information content present in given message, or average information per individual message is called entropy of the source. Now let us solve some more problems based on this, and let us see some important properties of entropy also. A source is emitting 3 symbols. A source is emitting 3 symbols. They may give 3 symbols or 3 messages, or sometimes even they may give discrete memberless source, DMS. 3 symbols x1, x2 and x3 with probabilities 0.6, 0.3 and 0.1 respectively. 0.6, 0.3 and 0.1 respectively. Calculate the entropy of the source. Calculate the entropy of the source. As I said earlier, entropy is nothing but average amount of information that is given by the formula h of x is equal to minus summation k is equal to 1 to m pk into log pk to the base 2. One thing you have to remember, to the base 2 we cannot directly use in calculator. That's what we have to convert to the base 10, so that we can directly use it in calculator. The relation is that log x to the base 2 can be written as log x to the base 10 divided by log 2 to the base 10. That means you have to divide with log 2. The value for log 2 is 0.3010. So by dividing with log 2, I can write it as 0.3010 summation k is equal to 1 to m. Here m takes 3 values, so 1 to 3 pk log pk. But here we have x1, x2. Let me write p of x1 log p of x1 to the base 10 plus p of x2 log p of x2 to the base 10 plus p of x3 log p of x3 to the base 10. Now the formula depends upon the symbol what it has been given. They might be given P1, P2, P3. You can write straight away P1, P2, P3. If it is given as x1, x2, then you make it as P of x1, P of x2 and so on. Now you substitute the values and find out what is entropy. So h of x will be 0.3010. P of x1, P of x2, P of x3 are given. So 0.6 log 0.6 to the base 10 plus 0.3 log 0.3 to the base 10 plus 0.1 log 0.1 to the base 10. Now use calculator and find out the value for this. You'll get entropy h of x will be 1.295 unities. As I said earlier, it will be bits per message or bits per symbol, depending upon what it is given. Here it has been given as symbol, so I have to write bits per symbol. So from this you can understand the entropy can be calculated by finding average amount of information per individual message. And let us solve one more problem based on this. Find the average amount of information. Find the average amount of information carried by a single possible message, carried by single possible message with P1 is equal to 1. Please go through once. They ask you to find average amount of information. As I said earlier, average amount of information is nothing but entropy. So the formula for finding entropy is entropy or average amount of information h of x is equal to minus summation k is equal to 1 to m pk log pk to the base 2. Here it has been given that only one message, so that two values given as 1. So I have to write minus 1 log 1 to the base 2. This can be rewritten as minus 1 by 0.3010 into log 1 to the base 10. The value for log 1 is 0, so this will lead for the value is 0. Therefore, entropy h of x is equal to 0. So when I have only one message with the probability of occurrence is 1, if you find the entropy, it will be 0. That means it does not convey any information, or average information is 0. So from this I can make some interesting properties for entropy. Some important properties of entropy. First one, the entropy is non-negative. The entropy is non-negative. That is, h of x will be greater than or is equal to 0. That means h of x may 0 or may be positive value. You take this example, their entropy was 0. You take this example, entropy was positive. So the entropy may be positive, may be 0. That's the first property. Then second property is h of x is equal to 0 if all the probabilities are 0 except for 1. All the probabilities are 0 except for the one which must be unity. except for the one which must be unity. Please go through once. H of x, entropy will be 0 if all the probabilities are 0 except for the one which is supposed to be unity. To prove this, let H of x entropy is equal to summation k is equal to 1 to m pk, or if I put minus sign, minus pk log 1 by pk to the base 2. Now let me write it for one symbol followed by remaining symbol. For one symbol they have been given that it is unity, so that is p1 log 1 by p1. Otherwise I can put minus sign log p1 to the base 2 plus limit p tends to 0, because for the only one case it is 1, remaining it is 0. So let me write limit p tends to 0 minus p log p to the base 2 plus p log p to the base 2 and so on. So since p tends to 0, this will be 0. Here I have only one message for which it is going to be unity. Already we have been solved for the case. If I have a message with the probability of occurrence 1, the entropy will be 0. So this value also, if you want, I'll write it, minus 1 log 1 to the base 2 plus 0. This value already we have been seen 0. So this will be 0. That means entropy will be 0 if I have all the probabilities are 0 except for one which must be unity. This is our second property for entropy. And third property is for an M array system. That means a system is going to have M possible messages. For an M array system, the meaning for M array system is a system is going to have M possible messages. Entropy H of x is equal to log M to the base 2 if all the probabilities are equal, if all the probabilities are equal such that pk is equal to 1 by m. To prove this, let entropy H of x is equal to summation pk log pk, or if I write plus sign here, log 1 by pk to the base 2. Now here it has been given that there are m messages, equally likely messages. So probability of getting every message will be 1 by m. Therefore here pk will be 1 by m. Here k varies from 1 to m. Now you substitute 1 by m here. So summation 1 by m log 1 by m, it can be written as log m to the base 2. Since the sum of our total probability is equal to 1, so it will become 1. So this will be equal to log m to the base 2. So the entropy H of x will be log m to the base 2 for M array system. You need to understand the sum of all the probabilities will be 1. That's what it will become 1. So you left out with only log m to the base 2. So I have been proved. So there are three important properties. One is entropy is non-negative. The other one is H of x will be 0 if all the probabilities are 0, except for the one it must be unity. And third one, for M array system, entropy will be log m to the base 2. Now let us see what is rate of information or information rate. rate of information. Notation is capital R. If a message source emits R messages per second, if a message source emits R messages per second, the rate of information is defined as the average bits of information per second is defined as the average bits of information per second is, that is, R is equal to small r into capital H. Already we have been seen where H is nothing but entropy of the source, which is nothing but average amount of information. Entropy of the source in bits per message. Small r is the messages per second. So if I put messages per second multiplied by bits per message, messages get cancelled, you'll get bits per second. Therefore, the unit for the rate of information is bits per second. I'll repeat once again. Rate of information is nothing but, assume there are R messages emitted by the source, then rate of information is given by the amount of bits, the number of bits per second is given by rate of information, which is expressed in terms of bits per second. Now, one thing you have to remember, assume that there are two sources I have, say S1 and S2. Both are going to have same entropy, say H and H here. I'll repeat again. Assume there are two sources whose entropies are H. Both are going to be equal. Further, assume that S1 is going to generate R1 messages per second. S2 is going to generate R2 messages per second. If R1 is greater than R2, then you find capital R1, that is rate of information for the source 1, and find rate of information for the source 2. Now, you look at it, R1 is greater than R2, so that one can write capital R1 is greater than capital R2. That means the rate of information generated by the source 1 is higher than the rate of information generated by the source 2, that is S2. From this, I can conclude the information conveyed by source 1 is higher than information conveyed by source 2. So from this I can conclude the source is not only expressed in terms of entropy, it also described in terms of rate of information. Rate of information. Now let us solve some problems based on this. An event has 6 probable messages. An event has 6 probable messages with probabilities. Messages with probabilities. P1 is equal to 1 by 2. P2 is equal to 1 by 4. P3 is equal to 1 by 8. P4 is equal to 1 by 16. P5 is equal to 1 by 32. And P6 is equal to 1 by 32 respectively. Find the entropy of the source. Find the entropy of the source. Also find the rate of information or information rate of information if there are 16 messages per second. If there are 16 messages per second. Please go through the question. They have given that event is having 6 probable messages, P1 to P6. They have been asked you to find entropy of the source. Also, they asked you to find rate of information. We know that the entropy of the source can be calculated by entropy h of x is equal to minus summation k is equal to 1 to m pk log pk to the base 2, or I can even write it summation k is equal to 1 to m pk log 1 by pk to the base 2. You can use either of the formula. Since it is given as 1 by 2, 1 by 4 like this, I can straight away use this formula. Or even you can use this, but you need a calculator for solving it. Therefore, entropy h of x is equal to, now substitute k is equal to 1 to 6. So you'll have pk, that is 1 by 2, but it will be in log to the base 2. We can write it log to the base 10, provided that you have to divide by log 2. 1 by 2 log 1 by 1 by 2, that is 2 to the base 2, plus 1 by 4 log 1 by 1 by 4, you can write 4 to the base 2, plus 1 by 8 log 1 by 1 by 8, so I can write it as log 8 to the base 2, plus 1 by 16 log 1 by 1 by 16, I can write it as 16 to the base 2, plus 1 by 32 log 1 by 1 by 32, I can write as 32 to the base 2, plus 2 times, otherwise 1 by 32 log 1 by 1 by 32, so 32 to the base 2. Since log 2 to the base 2 is 1, I can straight away write it, this will be 1 by 2, plus here I can write 2 square, that 2 I can bring it here, so 2 by 4 log 2 square, so log 2 to the base 2. Again log 2 to the base 2 is 1, plus 1 by 8, 2 power 3 is 8, so 3 by 8 into log 2 to the base 2, again it is going to be 1, plus 2 power 4 is 16, so 4 by 16 log 2 to the base 2 is 1, plus 2 power 5 is 32, so 5 by 32 log 2 to the base 2, plus again this is one more 5 by 32 log 2 to the base 2. Since we know log 2 to the base 2 is 1, everywhere you put it 1 and take LCM, simplify, we'll end up with h of x is equal to 31 by 16. The unit is bits per message. Here it is given as message. If it is given as symbol, you have to write it as bits per symbol. So the beauty of going for using this formula is that since it is 1 by pk is given, whenever you have a fraction, it will be easier to solve it without using calculator. Otherwise, it would have been use this formula. You have to use calculator. You have to simplify. That's depending on you. You can do it either way. Bits per message. So we have been found the entropy. The other thing they asked you to find about the rate of information. As I said earlier, rate of information is nothing but the average amount of bits per second, or average number of bits per second. Rate of information, capital R, is equal to small r into h, or h of x, entropy of the source. Since small r is given as 16 messages per second, therefore rate of information, capital R, is equal to 16 into 31 by 16. Now 16, 16 will it cancel. Here it will be bits per message. This is message per second. Message also will get cancelled. So you'll get 31 bits per second. So the unit for rate of information is bits per second. Now take one problem as homework and solve it by yourself. A source emits 4 messages. A source emits 4 messages with probabilities. 4 messages with probabilities. One by 3, 1 by 6, 1 by 4, and 1 by 4, respectively. Calculate entropy of the source. Calculate entropy of the source. Also calculate rate of information. Also calculate rate of information if there are 10 messages per second. Please solve it as homework and see to that you will be calculating entropy and rate of information. Just I summarize, today we started with what is information, what is entropy, what is measure of information, and we discussed about rate of information. Thank you.